Hi, today we're gonna talk about our group discussion about application of differentiation. First thing first, I would like to introduce for my group member, which is Muhammad Daniel Hafiz, me myself, Ezekiel Simpson Simon, and Muhammad Khairul Afiq. So, uh, then we would like to say thanks to our calculus lecturer, which is Madam Rosla, to make us to give us guide about for our group discussion, and then also thanks to my group members Cairo and Daniel for their extraordinary cooperation and hard work. Now let's get to our topic. Apply maximum, minimum, and minimum problem. Calculus application issues frequently involve function whose maximum or minimum value you want to find. The domain from which you must operate will be determined by the limitation specified or implied for such function. The extreme value theorem, the first derivative test, or the second derivative test should be used to determine the maximum or lowest value depending on the function and its domain. Okay, we're gonna look for some question. This is the question. At figure below shows a piece of wire length 200 cm is bent into the shape of a triangle ABF and a rectangle CDEF as shown. Given that BC is equal to DC. Okay. For the A, express X in term of Y. So now I'm gonna let my friend Muhammad Daniel Hafiz to tell about the solution about it.
For the question A, the question asks us to express x in terms of y. So the first of all, we need to find the perimeter, which is we can find in the question. Which a piece of wire length 200 cm is the perimeter. Then we need to add every value that we can find in each side, which we can see AB, BC, CD, DE, EF, and then FA. So we're gonna add seven. So we're gonna add all the value and we can get 7 plus 3y plus x plus 8 plus 3y plus x plus 8 plus x equal to 200. Then we're gonna calculate it for the next step, and then we could get 6y plus 3x plus 23 equal to 200. Then after the next calculation, we're gonna move 23 to the other side, which is make it 200 minus 23. Then we can get 177. Then we're gonna vectorize it until we get 2y plus 8 equal to 177. Then we move the 3 to the other side, then we can get 59. Then we left the x, then move the y, then 2y we get from previous, and we will get the answer x equal to 59 minus 2y. Now I'm gonna give my friend Carol Afik for answer the question B.
For question B, the question uh, asks to prove the area of triangle and rectangle, which is equal to 378y minus 12y squared. So this is the solution. Uh, First, we need to identify the formula of triangle and rectangle, which is one for triangle 1 over 2 xy, and the rectangle xy. After that, we we insert the value of the 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 length the length and height, which is the length is equal to x, and the height equal to 6y. And for rectangle, the width is equal to plus 8 x plus 8 times the length, which is 3y. After we got the answer, we we need to find the we need to prove we need to prove the area. From the answer of A, which is x equal to 59 minus 2y, with the equation we got from above, which is 6xy plus 24y, we insert the x value into the to x. After that we got the answer. The answer is the same as above, the area, which is a equal to 378y minus 12y squared.
For the question C, find the maximum area enclosed, which means we just use the area equation which we can find from B, which is A equals to 378y minus 12y. Then we need to differentiate the area equation, which is A in term of y. Then it's gonna become the A dy equals to 378 minus 24y. Then we need to find y value, so we can find the maximum value later. So we're gonna let dA dy equals to 0, which is gonna become 378 minus 24y equals to 0. Then we're gonna let 24y to the right, so it's gonna become positive. Then we're gonna let y alone at its side, so it's gonna become 378 divided by 24, it's gonna become 63 over 4. Then when we have found our y value, we're gonna substitute the value into the equation, the area equation, which is the A equals to 378y minus 12y squared. Then we're gonna substitute inside the y value, and it's gonna become 378 times 63 over 4 minus 12 times 63 over 4 square. Then the final value, we can find our maximum value, which is our final answer, which is 2097 2,976.75 cm square. So that's all for this question. Now we're gonna comes to the conclusion. The conclusion is the applied maximum value, maximum and minimum problem with the concept of application. Then find the derivative. Let the derivative equals to 0 to find the value of variables. Next, we use second derivative to find out whether it's maximum or minimum value. Last, enter the value in the equation. So that's all from us. Thank you.